Next we are going to see with law of equipartition of energy. Okay, so in this law of equipartition of energy, let us take the average kinetic energy which moves in the x direction to be equal to half m v square, that is vx, because it is moving in the x direction, that is equal to half k into t. Suppose when it is moving in the y direction, the same equation we are going to write. Instead of x, we are going to write as y. So half m vy square, that is equal to half into k into t. Same when you are considering for z direction, that is half m vz square, that is equal to half k into t. Okay, according to kinetic theory, the average kinetic energy of system of molecules in thermal equilibrium at temperature T is uniformly distributed to all the degrees of freedom, so that each degree of freedom will get half kT of energy. Okay, so according to kinetic theory என்ன சொல்றாங்கன்னா, the average kinetic energy வந்து which is at thermal equilibrium, அதுவும் temperature T ல, thermal equilibriumல temperature T ல இருக்கிற ஒரு average kinetic energy-ய என்ன பண்றோம்னா யூனிஃபார்மா டிஸ்ட்ரிபியூட் பண்றோம் to all the degrees of freedom. எல்லா degrees of freedomக்கும் நம்ம என்ன பண்றோம், அதை யூனிஃபார்மா டிஸ்ட்ரிபியூட் பண்றோம். ஸோ அப்படி யூனிஃபார்மா டிஸ்ட்ரிபியூட் பண்ணும்போது ஒவ்வொரு டிகிரி ஆஃப் ஃப்ரீடம்க்கும் நம்மளுக்கு என்ன கிடைக்கும்னா half kT of energy எக்ஸ்ட்ராவாக கிடைக்கும்ன்றாங்க. ஓகே, ஸோ they will get half kT of energy. Okay, see to this once again. According to kinetic theory, the average kinetic theory energy of system of molecules in thermal equilibrium at temperature T is uniformly distributed to all degrees of freedom. எல்லா degrees of freedom க்கு uniformly distribute ஆகுது, so that each will get half k into T. Okay, this we have seen already. What is the degrees of freedom? So degrees of freedom we have with three things: monatomic, diatomic and triatomic. இல்லையா? So அதுதான் நம்ம இங்க மறுபடியும் பார்க்க போறோம். Okay, and we have seen already for monatomic F is equal to what? 3. Okay, for diatomic we have it two things, that is at low temperature which is 5, and for higher temperature which is 7. Okay, next is for triatomic. So triatomically adedhaan, when you consider for linear it is 7, then non-linear we have F is equal to 6. Okay, so these are the things. First, monatomic molecule F is equal to 3. அடிஷ்னலாக என்ன கிடைக்கும், ஒரு half kT. ஸோ அதனால் இந்த 3 into half kT, ஸோ இட் இஸ் 3/2 kT. ஓகே, சேம் வே ஃபார் diatomic low temperature, low temperatureல F ஓட வேல்யூ என்னது 5. ஸோ F is equal to 5. ஸோ 5 into this half kT, ஸோ 5/2 kT. Yes, next again diatomic, but for high temperature, this is low temperature, F is equal to 5. For high temperature, F is equal to 7. Okay, so 7 into half kT, so it is equal to 7/2 kT. Yes, next is linear triatomic molecule. Okay, so for linear triatomic molecule, F is equal to 7. Okay, so 7 into 1/2 kT, so it is 7/2 kT. Next, non-linear F is equal to 6. Okay, so 6 into 1/2 kT, so 6/2 kT, so that becomes as 3 k into T. Based on this, we have the law of equipartition of energy in specific heat capacity of gases. Okay, so we have known with the values of this average kinetic energy, is it not? So average kinetic energy of monatomic molecule is what? 3/2 kT. Next, diatomic is 5/2, that is for low temperature, and for diatomic high temperature it is 7/2. Triatomic, linear triatomic 7/2, non-linear it is 3 kT. Okay, so using this all the values we are going to find with the next one. Okay, so in application of law of equipartition of energy, we are going to consider with the Mayer's relation. Okay, Mayer's relation is given by Cp minus Cv, which is equal to R. Okay, Mayer's relation which is Cp minus Cv, which is equal to R. This why we are using is because we are using with a specific heat capacity. We have to find with the specific heat of gas. Okay, so here we have the two specific heat for 1 mole of ideal gas. Okay, and so here Cp minus Cv and the ratio between them, that is given by gamma. Okay, where gamma is called as a adiabatic exponent. Okay, so where gamma is called as a adiabatic exponent, so that is given by Cp divided by Cv. Okay, Clear? So, first, for a monoatomic molecule. So, monoatomic molecule average kinetic energy value in 3 by 2 kT. Okay. Then, the total energy is given by total energy in the value into n. Okay. இப்போ இந்த k into n இருக்கு இல்லையா அதுக்கு பதிலா என்ன எழுதலாம்னா r அப்படின்னு எழுதலாம். Okay. So, k into n can be written as r. Okay. Next is this is what C V is equal to. Okay. So sorry, U is equal to U because this is a total energy. So U is equal to. Next CV கண்டுபிடிக்கணும். CV is equal to what? du divided by dt. So அப்போ இதை என்ன பண்ண போறோம்? Differentiate பண்ண போறோம். So we get d by dt அப்படியே எழுதிட்டு U க்கு பதிலா we get this term. So 3 by 2 RT. Yes. Now, if you differentiate this t get cancelled, and so we get just 3 by 2 r. Yes. Next, based on this equation, what is Cp is equal to? Bring this Cv this side. So we get Cv plus r. It's not. Now, substitute the value of Cv here. So we get 3 by 2 r plus r. So if you take the LCM, we get 5 by 2 r. So we have got the value of CV and CP. Next is we have to find with a gamma. Gamma is equal to what? CP divided by CV. CP is what? 5 by 2 R divided by 3 by 2 R. R get cancelled. Same way 2 get cancelled. So we get 5 divided by 3. So 5 by 3 is 1.67. Okay. So this is for a monoatomic molecule. Clear? Same way we have to do for all the other things. So what is the procedure is first average kinetic energy எடுத்துக்கிறோம் அது into n ன்னு எழுதுறோம் next k into n க்கு பதிலா என்ன எழுதுறோம் r ன்னு எழுதுறோம் okay this is the value of u next is we have to find with cv that is given by du divided by dt so இதை differentiate பண்ணும்போது அந்த t value மட்டும் cancel ஆடும் okay next we get with the value of cp which is equal to cv plus r. This is a formula. Then last formula is Cp divided by Cv. Gamma is equal to Cp divided by Cv. Okay. So next we are going to see for diatomic molecule. For diatomic molecule, first the average kinetic energy is given by 5 by 2 kT. This into n that gives you a total energy. Okay. Then k into n that can be written as r. Yes. Next is we have to find with the value of what? Cv. So Cv is equal to du divided by dt and so d divided by dt of u value is what 5 by 2 rt so here d by dt is missing okay so d by dt of 5 by 2 rt then t get cancelled so we get 5 by 2 r yes then next formula is cp is equal to cv plus r so 5 by 2 r plus r so we take the LCM here 5 plus 2 which is 7 by 2 r yes so this is cp this is cv so gamma is equal to Cp divided by Cv. So 7 by 2 R divided by 5 by 2. So R get cancelled. Same way 2 get cancelled. So we get 7 divided by 5 which is equal to 1.40. Clear? Same way this is for high temperature and that value is 7 by 2 R T already. Okay. So this when you are going to differentiate we get this R cancelled. So it is 7 by 2 R. So Cv plus R which is 7 by 2 R plus R. So 7 plus 2 which is 9. So we have got the value of Cp and Cv. So gamma is equal to Cp divided by Cv. So R get cancelled, 2 get cancelled. So 9 divided by 7 which is equal to 1.28. Yes. Next is triatomic. First linear. For linear the energy is 7 by 2 kT into n. K into n is what? R. Then Cv is equal to du divided by dt. So d divided by dt of 7 by 2 rt. This t get cancelled now. So 7 by 2 r. Next Cp is equal to Cv plus r. So this plus 2 which is 9. So 9 by 2 r. Again 9 by 2 divided by 7 by 2. So we get the value same as this. Okay, high temperature. This is for linear molecule. Next is for non-linear. Yes, so for non-linear, the energy is 6 by 2 kT into n. K into n is r. So this, if you divide, we get 3 RT. So this, if you are taking for CV, R get cancelled. Sorry, T get cancelled. So we get 3 R. Next, Cp is equal to Cv plus R. So 3 plus 1, which is equal to 4R. Cp divided by Cv. So 4 divided by 3. R get cancelled. So we get 4 by 3, which is equal to 1.33. Okay. So this is for non-linear. So these are all the values of the specific heat capacity for the diatomic, triatomic as well as a monatomic molecule. Clear with this? Thank you.